All right. So, how do you take these derivatives? Well, they all look similar, but they're all going to be different. That's why they're interesting. So, for A, so our outside function is the cosine function. So, the derivative of cosine is negative sine, and then the inside stays the same. So, negative sine of 3x squared. And then you multiply by the derivative of the inside. So, what's the derivative of 3x squared? That's 6x. So what do we end up with? Negative 6x times sine of 3x squared. Boom. Now B, they try to be tricky by having this cosine of 3 here. But remember, the cosine of 3 is just a number. It's just a constant. So just like if that was a 2 or something, it's just going to sit there. So we're just going to use the plain power rule here. We just got to bring the 2 to the front. We're going to multiply that by the cosine of 3. And then times x and decrease the power by 1. We should do that to be clear that that's just the cosine of 3. All right, good stuff. Now, this is not super clear in my mind of what this is supposed to be. I suppose they would have wrote the squared here if that's what it was supposed to be. So I'm going to assume it's not that. I'm going to assume that it's the 3x squared there. So I'm just going to simplify that first. I'm just going to rewrite that then as the cosine of 9x squared, and then take the derivative of that. So the derivative of cosine is negative sine. Inside stays the same. And then you multiply by the derivative of the inside. So bring the 2 to the front, 18x. So then I'll rewrite, what do you end up with? Negative 18x times the sine of 9x squared. And as long as that is like how I assume it's supposed to be written, that's correct. Because then you see D, they do use that notation. This notation means that what we're dealing with is the cosine of x squared. So here, the big outside function is the squared. So what do we need to do? Just power rule to start off. Bring the power to the front. The inside stays the same, so 2 times the cosine of x, and then decrease the power by 1, so just 1. But then we have to multiply by the derivative of the inside. The derivative of the inside is negative sine. So then we have to multiply by negative sine of x. And so what we end up with is, getting a little cramped, negative 2 sine of x cosine x as the derivative. And if you want to be really cool, 2 sine cosine x is the sine of 2x. So this is negative the sine of 2x. The derivative of the cosine squared of x is negative sine of 2x. That's pretty good. That's pretty good. Now the next one we're going to do similarly, because we're going to rewrite this as the cosine of x to the 1/2 power, and then we'll just roll with the power rule. So we'll bring the 1/2 to the front, 1/2. Inside stays the same, so cosine of x to the negative 1/2 times the derivative of the inside, which is negative sine. And then you make it a little prettier, I'd say. So let's rewrite this as sine of x cosine of x over 2. Except for no, that's not what it is. It's the sine of x, but then on the bottom, it's the square root of cosine of x. So just to line it up, it's the sine of x over 2 square root of cosine of x. Right? As you bring the 1/2 to the front, you decrease the power by 1, so that goes to the bottom. And what I don't know why I didn't think about this just right from the beginning. How I normally would have done this is just know that the derivative of the square root is 1 over 2 root, so then cosine of x, and then multiply by the derivative of the inside, which is negative sine of x. And that's what we got down here, right? I just dropped this negative right here. Brutal. So sometimes when I show my work, I make more mistakes. That's a thing sometimes. But that was some good practice. But you see, it's all just chain rule. These aren't really any different. It's just using the rules that we know to take the derivatives.